What's up everybody, how's it going? So this video is a bit different from my usual videos. Basically, I paired up with my good friend Rachit Jain. He's a pretty big YouTuber. He's an ex-Microsoft software engineer. He loves everything about algorithms and data structures, and so we decided to pair up and to do a mock coding interview where I was the person interviewing him over Hangouts on a Google Doc. This is exactly the kind of interview that you might get at a company like Google or at any other big tech company. And it's a very interesting one because Rachit did very well and he was able to get through two pretty difficult questions. And there's just a lot of little nuances and techniques and strategies to pick up from this video. So I really hope you enjoy it. It is a two-part video because it's a pretty long video. The first part is on Rachit's channel. I'll put the link in the description and in the comments below. I'd probably recommend that you start there and then move your way over here. But without further ado, enjoy. So, Rachit, I want to move on to another question, so something completely different, because I think we've exhausted the monkey theorem with pi and everything, but I do want to quickly cover the space and time complexity, if you could talk about that.
Sure. Let me see. So, talking about extra space, we are definitely using the DP array or vector, whatever you want to call that. We are also using a data structure for exist, which is doing that hashing thing. So, both of them are basically handling n states, so the space complexity will go order n.
Yep.
Talking about the time complexity, we have n states, and over here, since we are iterating on every possible prefix, for every length it can go in worst case order n. So in this way, the time complexity for this results in order n square.
And sorry, can you say again that last part?
So we have n states, right?
Yeah.
And for every state, since we are iterating on all prefixes starting from that particular position, so in the first case we will be having this j for loop will be executing n times. Then when we go to the next position, just give me a second.
And when you say the next position, it's like in that main function, right, where you iterate through all the characters in the string.
Right. So yeah, so in the worst case it can happen that the letter pi is all about 3.3333333, okay?
Right.
And the favorite array is having 3, 33, 333, 4 3s and so on. So what this will result in something like I will check, I'm at the 0th position, I check the first prefix, the second length, then third length, and everyone will result in true. And then basically I will end up calling check for every position from 0 to n minus 1. Right. So initially you will call for n, basically this j for loop will run n times, right? Then in the next case it will run n minus 1, n minus 2 and so on. And we know that results in order n square.
Right.
So but in our case since it's pi and it will never be 3.33 something like that, I think we'll need to dig a bit more deeper to exactly figure out what the real-time complexity will be.
Right. So we could do basically a more complex, like some kind of amortized analysis or something. But here I don't think it will necessarily be worth it. One thing to note though is we are dealing with strings, right? So with like current, like this line here, current plus equals pi j. You're recreating a new string. You have to reiterate through the entire string every time, right? Because of the immutability.
So no, in C++ it doesn't work like that. So appending a character to a string, it's order 1.
You're talking to a non-C++ programmer, so my mistake then.
Yeah. It's in C++ this is order 1.
Gotcha. But like if you were writing in Python or JavaScript here, then this would have been an interesting comment.
Right.
But okay, great. I think we've exhausted this problem. Let's dive into something completely different. Okay.
Sure.
So quick pause here. As you'll soon see, the question that I'm about to ask is a pretty difficult question to explain over a voice call. It's the kind of question where if you want to show an example input for the question, it's much better to do it on a whiteboard. And that was sort of my mistake as the interviewer to give this question in a phone interview. But I think Rachit handled it very well. Rachit was able to ask a lot of clarifying questions. He wasn't afraid to show that he just didn't really understand the question prompt. There are a lot of good lessons to learn from this. Are you familiar with binary trees?
Yeah, pretty much.
So basically, we're dealing with a tree that's got where every node of the tree has some value, and for the purpose of this problem, the values are going to be integers. And then every node can have one or two child nodes that are themselves binary tree nodes. Make sense?
Mm-hmm.
So you can imagine that we might have a binary tree that's like 8, 4, 3, 2, and then the 3 has like two children that are like -1 and 1. Okay?
Okay.
Something like that. Now, in a binary tree, there's something called a path. So a path is basically any sort of line or curved line that you can draw through the tree that traverses sort of nodes through the tree, with the caveat that you can only have, like, every node in a path has to be connected to only 2 other nodes. So for instance, you could have like 4, 8, 3 would be one path, right? Going from 4 to 8 to 3. Or 2, 4, 8, 3 would be another path. But what would not be a path would be 8, 3, 1, -1. Does that make sense? Because here you would have the node at 3 that would be connected to 8, 1, and -1. Are you following what I'm saying, or not really?
Can you please repeat?
Sure. So if you want, I will actually copy paste. I will copy paste a more comprehensive prompt. So right here. Whoops. Let me delete this. There. This is much prettier. So basically, you've got a binary tree, and you've got a path is a collection of connected nodes where no node is connected to more than 2 other nodes. And I want you to find the maximum path sum in a binary tree. So again, I guess if I were on a whiteboard, I would be able to sort of draw it out better. But in this example subtree here, in this sample input, you see, if you were to go from 2 to 1, and down to 3, that would be a sort of path that goes in a sort of triangle, right? 2, 1, 3.
Okay.
Or, for instance, 4, 2, 1, 3, 6. That would also be a path.
Okay.
What would not be a path would be something like 1, 3, 6, 7. Because here you've got a sort of like triangle thing where the 3 is connected to 3 nodes. Does that make sense?
So just to make sure, will this be a path 1, 6, and 3?
1, 6, and 3 would be a path, yes.
So basically, by path we mean a collection of nodes. So that node, basically for a given node, we don't have more than 2 nodes which are connected to it.
Exactly. So I guess this sentence here in the prompt really sums it up. Okay. A path is a collection of connected nodes where no node is connected to more than 2 other nodes.
Cool.
And you have to find the maximum path sum in a binary tree.
Alright, so for this case it's 18 as it's given out. Let me check why is that.
Yep.
I think we can pick 7, 6, 5 and 4. Once we do that, we cannot pick 3. We cannot pick 2 because 4, 5, 6, 7 all, and we can pick a 1. So that results in 6, 4, 10. I think that's resulting in...
How are you getting 6, 5, 4, and 7? Those can't be in the same path. The only way that you would ever get, basically at the bottom here, you would only be able to get 2 of the bottom numbers, right? So I think for 18, it would be 7 plus 3, 10, plus 1, 11, plus 2, 13, plus 5, 18.
Okay.
But does that make sense? How
so you basically what I mean to say is we can never go from 6 to 7. So what I got confused by that is I was thinking that we just have to come up with a set of nodes so that no no three of them are connected. But the question is not connected via direct edge. But the question is a bit different. So basically, I did not get the question correctly. So if I'm
Yeah. So go ahead.
so if I got this question right, it's basically as we talk about path is like moving from node X to node Y, right?
Yes.
And since it's a binary tree, I never think that we can go into that scenario wherein we are having 3 nodes in the path.
You could have 3 nodes in the path. You could have like 1,
Okay,
3, 7.
637.
Or 6, 3, 7, yeah.
Yeah, but 637 is fine, right? 2 are allowed, I think.
Yeah.
So what is not allowed? I think that so 1367 it's never a path because you have an edge from 1 to 3, but from 3 you can only pick either 6 or 7. You of course can't
Exactly.
pick both.
Exactly.
Okay.
So like
I think
so like 136 is a path, 137 is a path, but not 1367.
okay, so just give me a second.
Yeah, no problem.
Yeah. So basically, if I got this question right, what it actually means is, since it's a tree, for between any 2 nodes, there will be a unique path, right?
Yep.
And we do that for all the pairs, and then we basically compute the sum for each pair, like compute the sum of the path, and then we return the maximum one.
Yes, that sounds like it would return the correct result. You're saying basically compute the sum of every single path is what you're saying.
Yeah, essentially, yeah. And the number of paths can be basically the number of unordered pairs x comma y, where x comma y are nodes from the tree.
Sure.
Right. Okay. All right. So essentially, what is coming to my mind is nothing but we can query the left subtree to give the maximum path length starting from that particular root. So just to make it more sense, let's say RootMax u is giving me nothing but the max length path starting from u within its subtree. Let's say the tree is rooted at node 1, for example. Okay.
And just sorry, what is u?
So it's a parameter. This is a function RootMax. It takes in a parameter node u, and it returns me the maximum length path starting from u, which means starting from the root.
Yeah.
Because within its subtree.
Okay, sure.
Another thing can be PathMax u, which is nothing but max length path within the subtree of u. Make sense?
Sure. Right.
So this can be different from RootMax because RootMax has another constraint that it is starting from the root.
Right.
Wherein in PathMax the path can even bypass the root and it won't even include that.
Okay? Yes.
So I think the answer for our problem will be PathMax 1. If again I'm saying I am explicitly rooting the tree at 1.
Yeah.
Okay? So this is what our answer is. And I'll just zoom in a bit so that while it's getting recorded, people can see this. Okay.
Yeah.
PathMax 1 is the answer. And how can we say what is PathMax? So of course, for given PathMax u, something like this, it is nothing but PathMax of u left. So basically, we query both of the left and right subtrees for the given node u to check for the maximum PathMax in their subtrees, right?
Yeah.
Now the only thing which is left is to check the RootMax for u, right?
Right.
So this is a, I think, fairly straightforward recurrence equation. Like for the given node u, to compute the PathMax for that, you can either query the left and right child's PathMax, and the other option is to compare the root max from the given node.
And so how do you get root max of u?
Exactly. So we need another recurrence equation. So root max u is already included. So the value of u will definitely be there, right?
Mm-hmm.
And then we can basically call max of root max of u left as compared to the right. So we have to go either way, we cannot go both ways.
Right.
So yeah, this will solve this.
Are you sure that that last line is correct?
Yeah, I'm pretty much sure.
So root max of u, you're saying, would be equal to the value,
Right.
which would be like, let's say we were to call root max of the entire example here, the sample input. So the value would be 1.
Right.
Right? So this would be equal to 1 plus
Root
maximum
max
of
2 and root max of 2 and 3.
Of 2 and 3.
Yeah.
But root max of 2 would be 425, right?
No, so root max is basically that path is starting from that point. So it can be either of 24 or 25.
Oh, I see. Okay. So when you say it starts at that, that is an extremity, is what you're saying.
Yeah, it's the starting point of that path. So 4 to 5, 2 is coming in between. It's not the starting or ending point.
Okay. But so then your formula here, mathPax of u.
Correct.
Okay, so then here going forward, then you would have max of 2 plus 5, right? Or sorry, max of 2 plus 5, comma 3 plus 7.
Right.
Right?
Right.
Which would be equal to 1 plus 3 plus 7, so it would be equal to 11, right?
So root max of 1 is 11.
Yeah, but so then here mathPax of u would be equal to max path u left, max path u right, or 11.
Yeah, so one case that we have not considered right now is that, so let's see what PathMax is denoting basically, right?
Sure.
So in PathMax, we are querying the left subtree PathMax, the right subtree PathMax, which covers a lot of difficulties that we couldn't otherwise actually compute. So a lot of the possible PathMaxes are already covered from the left and right subtrees. There are now few cases that we need to consider. So one is the root max, and the other is we can basically join the root max of the left and right as well. So that's another thing that we have not yet considered.
Right.
So instead of root max, I think the best case is to get the root max from the left and right and add the current value as well in that. So just to make this, let's take this over here because this recurrence relation is going otherwise too wild.
Sure.
Let's say something like, I would say, I'm not sure with the naming, so let's call that X. Oops, where did I go? Yeah. So let's call that X, and X is nothing but current node's value plus the root max for the left subtree plus the root max. So basically I'm joining the paths.
Okay.
And this will also add as one of the candidates for the PathMax of u.
So now you're saying the PathMax of u is equal to the maximum of the PathMax of the left one, the maximum of the PathMax of the right one, or X, which is the joining of the two root maxes plus your current value.
Yeah, because we have considered all the paths now.
And root max, again, just to clarify, root max will always be a line.
Yeah,
starting. Like root max will always be starting from you. Okay.
Yeah.
Okay. So then here again, you would have X, just to make sure that we're on the same page, you would have X equals, oh my god, X equals 1 plus 2 plus 5 is what? Is 7 plus 10, right? That would be that. And PathMax would be the maximum of, it would be equal to max of 2 plus 5 3 plus 7, and 1 plus 7 plus 10, 18, right?
No. So PathMax for u is basically having PathMax for u's left and u right. So this is not RootMax. So we cannot use 2 plus 5 and 3 plus 7.
Oh, right. I see. Right.
So this will be 2 plus 4 plus 5. And this will be 3 plus 6 plus 7.
Right. Okay. Sure. Fair enough. And this would still give you the correct answer of 18.
Right.
Okay. But then, however, what happens if... What happens if the root max of u left... Let's assume that the root max of u left, instead of being 7, let's assume that these are all...
Just hold on for a second. A phone
no problem. No problem. Everybody, if you're in an interview, don't have phone calls ringing in the middle of your interview.
I'll be back.
No problem. Okay, I'm resuming the timer. So what happens if imagine on the left side, instead of 2, 4, and 5, I had -2, -5, and -4. Okay. And so now you have you have x equals 1 plus root max of left plus root max of right. Root max of right is still 10, right? We agree that it's still 10.
Sure. I think I can clearly see the problem with this because I didn't deal with negative number cases right now. So what we need to do is basically, if something is giving us a penalty, right, we better do not even include that in the answer because it's making us a bit smaller.
Okay.
Right.
Last little note here. I'm not sure if what Rachit said just there was entirely correct about, checking if a number diminishes the entire path sum and eliminating it if it does. We would have to kind of dig more into that. But I do want to make it clear that I had already gotten a lot of good signal from Rachit from the first interview question that he sort of did very well. And here with the second interview question and the little time that we had remaining, I just wanted to kind of see, okay, can he sort of handle the question overall? Can he maybe write a bit of pseudocode? I wasn't really interested in going too far in details in that question. If it had been the only question I asked in the interview, which I could have, with most candidates I would probably only have time to go through one question, I would have definitely made sure that we go into detail there and make sure that, he is actually doing the correct thing. Because you can have a negative number in the max path sum, depending on, if there are huge numbers below it or whatever. But so that's sort of why I kind of accepted what he said, and just kind of moved forward.
So what I mean to say is that instead of adding that, because we were hoping that it will contribute and enlarge the answer, since it's giving negative, we'll first have a check that whether it's greater than 0. So if it's positive contribution, only then we compare that.
Sure. Gotcha.
Yeah.
And what does the time complexity look like of this algorithm? Space-time complexity?
I think we are using, of course, n more states. So there we go. Order n is the space complexity. And since we are doing a simple DFS traversal, which is again order n, the overall time complexity stays down at order n only.
Gotcha. Okay, cool. We have 2 minutes and 30 seconds on the clock. Let's just see if we can try to code something out. Don't worry too much about edge cases. Let's just see if we can, make this pseudocode into real code.
Cool. Awesome. So let's say we have something like RootMax, and it's having node star u. I will simply write the pseudocode because not everyone is a C++ developer.
Sure, yeah, no problem.
I'm sure that most of the viewers are also not C++, so yeah, it makes sense to go forward with the pseudocode. So RootMax u, let's call that as a function def, and then what we can do is basically have this recurrence, something which I have written at the top. Okay, so this looks good. One thing is, similarly we need to have something for the PathMax. I have written this also somewhere. Cool. My god.
Don't worry about it.
So yeah, we are doing something like answer is this, and then we can of course store this in some path. Let's say PathMax U is answer, just to have that DP kind of flavor.
Sure.
And over here we can have something like RootMax U is answer. And of course, before doing this, we can have a simple check, like if U is null. I'm not sure how null works in Python, but yeah, if U is null, we can simply return a 0 over here.
Right.
Similarly, we can do something like this here, return 0. And while we were talking about that negative number scenario, right? The thing is, what we can do is over here, when we are taking the RootMax, like for U left and U right, we actually want to return 0 in the other cases, right? Yeah.
Whoops.
I think. How shall I take care of that? I think we can do answer is max of answer comma 0. Make sense? Yeah, probably yes.
Yep.
So that will take care of that. So basically, when let's say there is a negative number, right? Yeah, yeah. So when we are at leaf node, and if it's negative, we simply store the root max for that as a 0 instead of that negative number.
Gotcha. Okay, so I think overall, like right now, the timer ran out, so we're sort of out of time. I think we can call it here. We can end the interview here, and if you want, we can sort of enter the debrief session.
Yeah, sure.
So first of all, I like how you called how you basically called Python pseudocode. But so yeah, overall, I think that you did like a really good job, because you basically went through two difficult questions in one single interview. I wasn't expecting you to go through both of these questions. In fact, I was debating on which question to ask you during this interview, but I didn't expect to ask both of them. I did have them both prepared just in case. But so from that point of view, I think you did really well. You know, from the point of view of like, how much does this candidate go through? You basically completed or almost completed both difficult questions. Also, if we go back to the first question, I think that you did everything sort of correct in that question, and that you asked a lot of questions at the beginning to sort of clarify the information and to make sure that you understood what the problem was. Then you kind of walked me through your logic with pseudocode, with this. You sort of teased me with a greedy algorithm, but then immediately like brought up the DP solution and the basically like the optimal version of the solution. And yeah, and then you sort of walked through your entire code pretty well. Like, I didn't even as someone, by the way, FYI for those of you watching, I don't write any C++. So even as someone who doesn't write C++, I was able to follow you very, very easily along, and I think that was in large part because you were sort of communicating well throughout the process. Did you, by the way, did you as the interviewee, did you feel like you were doing well, or?
Yeah, I mean, so I have spent like a lot of my time solving problems for data structures and algorithms. So whenever, even when I'm in interviews, someone asks me a question, I just go into that mode where I was all about solving problems, and I really love that. This is like a passion for me.
Right.
And I really don't care how am I performing at that time. All that is going on in my mind is there is some problem, and it actually sounds interesting to me. I'm not sure why, but it's actually kind of a passion for me to solve problems. And while I'm solving that, I just have one focus on my mind, like it's an interesting problem, let me just have fun with it, something like
right.
that.
And so I'm very similar to you in that, like, I remember when I first got into coding interview problems, I really enjoyed doing them. And I think that would be a piece of advice that I would give to all of you watching and all of you like preparing for your interviews, is that if you do what Rachit just described here and treat the problems as like just a fun puzzle or challenge that you're trying to solve almost together with the interviewer, you will not only have a much better time, you'll have more fun, so to speak, but you will also likely just perform better. And here,
Right.
that was clear. Like, Rachit just did a really good job because he was just kind of solving this problem, right? Also, one thing that I wanted to say that you did really well, Rachit, if we go to the second problem. So again, first of all, for the second problem, we really didn't have much time. Like, we only had like 20 minutes for the second problem. So that was already pretty rushed from that point of view, but you still handled it well. But also, I think you all saw that the explanation that I gave for the prompt of the second problem was kind of poor. And here, I'm going to take the blame. I didn't do a good job of like presenting the problem, especially before I copy pasted this full prompt. By the way, the full prompt comes from, this is a problem on Algo Expert, the second one. The first one I sort of came up but it's not there. The second one is on Algo Expert. It was very hard to describe and to give an example of a path without like a whiteboard where I can kind of draw the path. And yet Rachit was able to sort of handle that situation pretty well, and handle the confusion pretty well. He didn't get like nervous or anything, which I think played to his advantage there. And yeah, otherwise, again, like I think he went through the sort of pseudocode. He gave out like the first thought that Rachit gave out was this thing of like calculating all the pairs of paths, the whole XY thing. That was sort of, I think, a good like just first idea to kind of throw out there is like, oh yeah, this is something that we could do. It doesn't seem like he really used that afterwards, but like, it sort of got him on the correct footing, or on the correct path, pun perhaps intended. And yeah, I mean, again, overall, I think really good job for a 45-minute interview with a couple of like interruptions in the middle.
Yeah. Thanks.
All right, so that's probably gonna be it for the video. I hope everybody enjoyed watching it. Hopefully, everybody was able to get inspired by Rachit's like insane algorithm skills, and I think that'll be it. Any last words, Rachit?
Yeah, sure. I just wanted to mention that I'm definitely sure that this video will be super useful to a lot of viewers, because we really delved into a lot of things like how you have to approach problems, and also the debrief was super exceptionally good. Like I actually forgot that while you were taking the interview, you were also taking the points into account and you were making notes. So I think that's a terrific job. But other than that, I think I really didn't know that this question is from Algo Expert. And just to double iterate on that, I think for beginners especially, you guys have done really a great job, because the video explanations are like tremendously easy, and they go really into a lot of depth to cover the time complexity, space complexity, and more than that, you also try to cover what are the initial ideas which are coming to people's mind which won't work. So in that sense, I think beginners are really taking advantage of your Algo Expert portal, and that's something which I really would suggest my viewers as well to definitely go and check out. So guys, algoexpert.io/Rachit, and you can find the necessary links in the description. Yeah, that's all from my side, and thanks for taking out this time, Clement, and I really enjoy talking to you, and let's do something like this again in the future.
Definitely. All right.
Awesome.
See ya.
Right, bye.
So that's going to be it for this video. I really hope that you enjoyed it. If you're new here, or if you haven't already subscribed, then definitely subscribe. I post 3 times a week. You don't want to miss out on that content, and I will see you in the next video.